Welcome to the unit on quadratics, real-life questions. The objectives for this session are to explore real-life problems involving quadratics. Let's take a look at modelling with quadratics. A mathematical description of a real-life scenario is called a mathematical model. It helps us to explore real-life patterns and relationships and make predictions. Projectiles' motions, amongst others, can be modelled by using quadratic functions. Take a moment to read this example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at the example 1 scenario. A ball is thrown from the top of a tower. The height of the ball above the ground in meters after t seconds is given by the equation h of t equals 53.25 plus 17.9t minus 23.2t squared, where of course t is positive because t represents time. Now if we consider a tower and the ball is thrown from the top of this tower, then it falls in this kind of motion. So it's a projectile, or it takes the shape of a quadratic, as shown. Suppose we consider a point at which the ball passed through at a particular point, say here. H of t denotes the height of the ball above the ground, and t denotes the time that has elapsed. Now example 1 part A asks you to interpret the meaning of the constant term 53.25 in the model. Now when t is equal to 0, or right at the very start, h of 0 equals 53.25 because the other terms disappear. Therefore the height of the tower is 53.25 meters. Part B is asking, how many seconds does it take for the ball to hit the ground? Now when the ball hits the ground, the height of the ball above the ground is 0. So we can let h of t equal 0 and then find t by solving the quadratic. In other words, 23.2t squared minus 17.9t minus 53.25 equals 0. We've simply rearranged h of t equals 0. Now when we solve for t using the quadratic formula, we obtain t is equal to 1049.44 to 2 decimal places, or t is equal to minus 54.64. However, as we know, t represents time, and therefore t cannot be negative. So t is in fact equal to 1049.44 seconds to 2 decimal places. Now consider example 1c. Express the equation h of t in the form a minus b times t minus c all squared, where a, b and c are constants to be found. Give your values correct to 2 decimal places. Now h of t can be rewritten as shown. So we've isolated the 53.25 minus and then put 23.2 and the rest of the equation in brackets. Now for the bit in brackets, we use the method of completing the square. So So h of t can now be re-expressed as shown. And multiplying out the last bit, and then tidying up a little bit, gives us the expression shown. And tidying up some more, add the constants, and tidy up a bit inside the brackets. Giving us that a is equal to 56.70, b is equal to 23.2 from here, and c is equal to 0.39 from here. And now for example 1D, we're required to find the maximum height of the ball above the ground and the time at which this is reached. Now from part C, we have that h of t is equal to 56.70 minus 23.2 times t minus 0.39 all squared. Notice that the part of the equation in the red rectangle is positive. We have 23.2 times a real number squared. So if we're taking away a positive number from 56.70 and we want the maximum, then we need to ensure that that bit that we're taking away is as small as possible. And the smallest this value could take is 0. So the maximum height occurs when t minus 0.39 all squared is equal to 0. So this implies that t is equal to 0.39. And plugging this into our equation gives us that h of t is equal to 56.70. So the maximum height of the ball is 56.70 meters, 0.39 seconds after the ball has been thrown. This brings us to the end of this session. If you have understood the content of this session, you should be able to explore real-life problems involving quadratics. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to it.